RAAS stands for the Renin-Angiotensin-Aldosterone System, a hormone system that regulates blood pressure and fluid balance in the body. First, let's understand the components of RAAS. R stands for renin, A stands for angiotensin. The second A stands for aldosterone. Activation of RAAS. The RAAS is activated when there is decreased blood pressure, hypotension, or a decrease in sodium levels in the blood. When blood pressure drops, it leads to reduced kidney perfusion, the flow of blood to the kidneys. As the kidneys receive less blood, they sense this decrease in pressure. Juxtaglomerular cells, specialized cells in the kidneys, respond by releasing renin, an enzyme, into the blood. Similarly, when blood sodium levels drop, it is sensed by specialized cells in the juxtaglomerular apparatus called macula densa, which also triggers the release of renin into the blood. In both cases, the level of renin in the blood increases. The liver produces a special protein called angiotensinogen and releases it into the blood. This protein is always present in our blood. When renin is released by the juxtaglomerular apparatus, it converts angiotensinogen into angiotensin I in the blood. Angiotensin I travels through the blood to the lungs, where a specialized enzyme called ACE, angiotensin converting enzyme, present in the pulmonary capillaries, converts angiotensin I into angiotensin II. Angiotensin II is the active form of angiotensin. Angiotensin II, actions and effects. First, angiotensin II causes the constriction of blood vessels, both arteries and veins, by binding to its receptor on the smooth muscles in the walls of the vessels. When these vessels are constricted, systemic vascular resistance increases, which leads to a rise in blood pressure. Second, angiotensin II stimulates the release of aldosterone from the adrenal cortex. Increased aldosterone levels in the blood act on the nephron's collecting ducts, increasing the reabsorption of sodium and water into the bloodstream. Aldosterone also increases potassium excretion in the urine. Increased water reabsorption leads to a rise in blood volume and blood pressure. Third, angiotensin II increases thirst by acting on the thirst center in the hypothalamus, leading to increased water intake, which further raises blood volume and blood pressure. Fourth, angiotensin II enhances sympathetic stimulation in the body through two mechanisms. Angiotensin II crosses the blood-brain barrier and acts on the sympathetic centers in the brain, increasing sympathetic outflow to the periphery, thus increasing sympathetic nervous system activation. Angiotensin II to AT1 receptors on neuron axon terminals, both in the central nervous system and peripheral nervous system, enhancing the release of norepinephrine from sympathetic neurons, further increasing sympathetic nervous system activity. Summary of sympathetic effects. Angiotensin II increases sympathetic nervous system activity, leading to 1. Increased heart rate, 2. Increased cardiac contractility, 3. Increased constriction of blood vessels, increased heart rate, and contractility boost cardiac output, while blood vessel constriction increases total peripheral resistance, TPR. Together, these effects increase blood pressure. Fifth, the efferent arteriole of the kidney has a high number of angiotensin II receptors. Angiotensin II exerts a strong vasoconstrictive effect on the efferent arteriole, increasing its constriction. This constriction enhances the glomerular filtration rate, GFR, maintaining kidney filtration even when kidney perfusion is low during hypertension. Sixth, angiotensin II has growth and hypertrophic effects on the heart. During heart failure or prolonged low blood pressure and kidney perfusion, chronic activation of the Renin-Angiotensin-Aldosterone System, RAAS, increases angiotensin II levels. Pathologically high levels of angiotensin II cause myocardial growth, hypertrophy, by binding to AT1 receptors. Angiotensin II also promotes heart fibrosis, leading to heart stiffness and chronic hypertrophy, known as cardiac remodeling, which can worsen heart failure and eventually lead to death. Summary: how low blood pressure and low plasma sodium, normalized via the RAAS decreased blood pressure or low plasma sodium levels, stimulate increased renin release from the kidneys. Renin acts on angiotensinogen, a protein produced by the liver, converting it into angiotensin I. Angiotensin I travels to the lungs, where it is converted into angiotensin II by the enzyme angiotensin-converting enzyme, ACE. Angiotensin II increases the release of aldosterone from the adrenal cortex to increase sodium and water reabsorption into the bloodstream. Additionally, angiotensin II activates the sympathetic nervous system, increasing cardiac output and total peripheral resistance, TPR, which raises blood pressure and normalizes it. The increase in sodium reabsorption raises plasma sodium levels, normalizing low sodium levels. Thank you for watching. Stay curious and keep learning.